Yeah, because now it says 2 viewers. So my guess would be that that would be you two. And if it's just going to be you two, then we don't have to do it on here, but. Yeah, because now it says 2 viewers. So my guess would be that that would be you two. Yep, there's a delay. Thanks. And if it's just going to be you two, then.
I didn't do anything.
I don't know why, but the question part of this is not working. So if you are currently watching this, if you go back to the page where you found the video for this, underneath the video, if you do have a question right now as we are kind of trying to get through this, down below the video, back on the review session page, before you clicked on the start, say something there. Otherwise, we'll get started. Ha ha. I think I got it. I think I figured it out. Something else, guys, go ahead and get your review packet out. That's us. You should be able to see everybody that's in there. Is that you? I don't know why yours looks different. I have two different views. I open it up just like you guys do, and it gives me this green thing down at the bottom.
You're special this one.
Okay, until we figure this thing out, and I don't know why it's not doing what it's supposed to be doing. What questions do you guys want to start with on your review? Is there anything in particular? Where do you guys want to start on your review? What are you struggling with the most? Because you're supposed to come prepared to this with questions.
Yeah, polynomial.
Polynomials.
Yeah.
All right, so there are two other people watching us. And I'm not really sure why it's not working, because the two that are here cannot see the question button, and I'm not really sure why that is, but we are going to start with polynomials. So if you should have your review packet out at this time, let's go ahead and start with adding and subtracting polynomials, just as a little bit of review. And maybe some kinks will work themselves out. All right, adding and subtracting polynomials. And I'll project this so you guys can see what I'm doing. Just for those at home, I have two people in my classroom that I have to communicate with as well. Adding and subtracting polynomials. So as we go ahead and we start taking a look at adding and subtracting polynomials, it is important to remember when we're adding and subtracting polynomials what like terms are for polynomials. So in order for terms to be like, they have to have two things in common. The first thing they have to have in common is the fact they have to have the same variable. and they have to have the same exponential power. If our terms do not have the same variable and the same exponential power, then they are not considered like terms, and therefore I can't put them together. So if I have two things like 3x and 4y, I wouldn't be able to put these together because they're not the same variable. I would be able to put them together if they're the same variable because they do have the same exponential power, but they have to meet both. So in order for us to put these together, they either have to both be x's or both be y. So if they were something like 3y and 4y, and I'm adding these together, all I have to do here is add my coefficients. So my coefficients 3 and 4 would give me 7. But I don't have a rule, an exponent rule that says if I have two y's, that when I put those together, that causes anything to change. So I'm just going to end up with 1y when I add. One problem, though, that I see most often with polynomials is the idea of subtracting. And the reason that subtracting is difficult is because when you have an entire expression behind a subtraction sign, this subtraction sign indicates that everything following that subtraction sign is being subtracted. And the main error that I see with something like this is that it's subtracting just the 3x, and that subtraction doesn't get over to the 5. So you would have a subtraction of 3x as well as a subtraction of 5. So make sure that if you have subtraction, that gets distributed to both of your terms in the parentheses. However, if I do have something that follows this, like another expression, this subtraction sign would only be distributed to the expression immediately behind it. It wouldn't be distributed to both of these. It would just be distributed to the one that's directly attached to it. So let's go ahead and actually put these together. This has addition, so I don't have to worry about these two being together. So I'm going to go ahead and just bring those down. Now there's a couple different methods in terms of adding and subtracting polynomials. I'm the color person, so I like to make sure that my like terms have different colors. If you're one where you want to stack this so that like terms are underneath each other, you can do that as well. So then I have to ask myself, how do I put these together? Again, just like up here, I add my coefficients together, but I leave the variable alone. So -3 plus 2 would give me a -1. And again, you don't need that -1 there. And then you would combine your constants here, and you would get a -2. So because I'm having difficulties with that question app working, if you have any questions that you specifically want to go through, it would probably be best at this point in time to email them to me. So those questions that you have, go ahead and just email them to me because I don't know why that question button isn't working. And so I'm just going to pause here for a few seconds for those of you who have questions that are watching to send some questions in. Are you on your Chromebook, Brian? Or are you on a computer? Because we're thinking that the problem here is that the button is blocked on our computers here at home. Do you have a question, Brian, or are you just making me feel like I'm stupid with technology? All right, I now have some questions to go off of. Vika, you won't actually have to complete the square. Everything can be done by factoring. So I would review factoring. I mean, if you wanted to complete the square, you could, but everything on the test can be solved by factoring. The other question that I have is from Peyton, and Peyton wants to know the difference between disjoint and overlapping. So if you go ahead and turn your review to the disjoint overlapping stuff towards the end of your review packet. This is the question that deals with the probability. And remember, when we're dealing with disjoint or overlapping events, disjoint and overlapping events are signaled by the word or. So we want event A or event B. So if you're looking down at the bottom of the probability unit, the disjoint overlapping starts to come in with the question, the probability of orange or black. And so when we're talking about or, if it's disjoint again means that I can't have, the events don't occur in the same, the outcomes don't occur in the events. So it's like rolling a die. You can't land on 1 and 6 at the same time. Or if you're spinning a spinner, you can't spin a 1 and a 3 at the same time. So landing on a 1 versus landing on a 3 would be disjoint. So looking at the first one here, it says the probability of orange or black. These would be disjoint because I'm pulling one marble out of the bag at a time. So I can't pull an orange and a black marble out at the same time. So these would be disjoint. So all you would have to do for disjoint is find what is the probability of the orange marble. And then when I have or, that indicates addition plus the probability of the black marble. Now, because this is disjoint, you don't have to worry about subtracting. Now, if you look at the back of that page, when it starts to talk about, let me see if there's any on here, because those are independent, dependent. Overlapping would be something like if I have a spinner that has numbers 1 through 8 on it, and I'm spinning a spinner, I want the probability of landing on odds or a number greater than 5. It's possible in a situation like this on a spinner that has numbers 1 through 8 on it to have some of your events that occur here to also occur here. So my odds on a spinner 1 through 8, again, I like to list out my possible outcomes. So that would be like 1, 2, 3, 4, 5, 6, 7, and 8. Your odds would be 1, 3, 5, 7. So you have 4 favorable outcomes out of 8 possible. So that's the probability of getting odds. And then we want to also figure out what is the probability of a number greater than 5. And again, this is greater than 5, so it wouldn't include 5. So I'm looking at 6, 7, and 8. So that would be 3 possible outcomes out of 8. Again, it's or. So I would add. I would get 7 out of 8. And then I have to go back and ask, well, did any of the odds, the 1, 3, 5, 7 that occurred in the first event also occur greater than 5? And so 7 happened to occur in both of those events. So I would subtract away that one event that was duplicated. Both showed up both here and here. And you get 6 out of 8, which would reduce to 3 out of 4. The next question that we have is over factoring when A doesn't equal 1. So that would be on your not solving. You can solve, I guess. This is on your down towards the bottom when it said factoring when A does not equal 1. Now, the process of factoring when A doesn't equal 1 is very similar to factoring when A does equal 1. And so the only difference is that you have a value in front of A. So here's your typical trinomial. So you have A, B, and C. And when A is 1, there's nothing there. But if A is more than 1, we're going to have a number there. And the only thing that changes about this, so let's go ahead and actually come up with a question. Let's do the 7x squared plus 4x minus 11 from your review sheet. We're still going to create our X puzzle. On the top here, however, instead of just putting C like we normally would when A equals 1, now we're going to multiply together that coefficient that's in front of the X squared with the constant. So I'm going to multiply A and C together. And so 7 and then negative 11 would get me negative 77. And then B would still go on the bottom like it does when I'm factoring when A equals 1. So 4 would go down here. I'm still looking for 2 numbers that would multiply to get the negative 77 and still add to get 4 on the bottom with one little twist. So 2 numbers that multiply to get 77 would be actually the 2 numbers that I started with, the 7 and the 11. But I want the 77 to be negative, so one of these numbers has to be negative. But I want a positive 4, so the number that has to be negative to make both of these true would have to be the 7. Now, the trick with having a number in front of the A value is the fact that since I multiplied it to get the number on top, at some point I'm going to have to take it back out. And so when I take it back out, I'm going to actually divide both of those factors by the number that's A at this point and see if anything can reduce. 11 over 7 does not reduce. Negative 7 over 7 does reduce, and that reduces to a negative 1. So then I'm just going to write these 2 factors that I have left over, x minus 1 and then x plus 11 over 7. And then anytime that I have a fraction in terms of one of my expressions, I need to do that bottoms up maneuver where I take the bottom of the fraction, put it in front of my x, and then rewrite this as x minus 1, and then that 7 comes in front, plus 11. Now, if you're not sure whether or not you got the right factors in there, you can always go back and multiply those 2 together. Our next question takes us to maximum and minimum from the quadratic unit. So this is the page on the back of the graphing where it says maximum and minimum at the very top. Now remember, when you're talking about maximum and minimum of quadratic equations, maximum and minimum have to do with the vertex of the parabola. And the vertex can be found by using the equation negative b over 2a. So let's say that we have an equation. Most of the ones that we have look something like this, where we're missing the b value. So if I'm missing the b value, that means that b is 0 and therefore has eliminated that x term. So when I plug b into this equation, I would get 0 over something. And in this case, it would be 0 over 8. And 0 over anything would just be 0. But by doing that, you're just finding the x value of your vertex. So in order for us to find the complete value or the maximum and minimum, I have to plug that value back into x and solve to get my y. So if I plug 0 in here, 0 squared would be 0. 0 times 4 would be 0. 0 plus 5 would give me a value of 5. And this would be your vertex. Now, in order for you to decide whether that vertex is a maximum or a minimum, you have to think back to the original equation. This number out in front of your x squared term will give you the answer to whether it's a maximum or a minimum. This is a positive, which means that my parabola opens up, which means that vertex that shows up right here is going to be a minimum. On exponents, yes, when the exponent of something is 0, it's always going to equal 1. But it depends on what the exponent's attached to. If you had something that looks like this, then the 0 is only attached to the x. It's not attached to the 2. So only the x would equal 1. But then that 2 would have to be multiplied by that value of 1. Whereas if I had something that looks like this, where the 0 is attached to the entire quantity of 2x, then this whole entire thing would equal 1. But in this particular case, where the 0 is only attached to the x, just this portion would equal 1, and then you'd have to multiply that number by 2. I'll let that catch up for a second because I'm currently out of questions. Our next question is over exponent properties. So just a quick recap. If I have two variables that are being multiplied together, something just as basic as this, I'm going to add my exponents. Now, if come to a test, you can't remember whether you add or multiply, what I would do is I would expand this. What does x squared mean? X squared means x times x. What does x cubed mean? X times x times x. So if you need to expand these out so that you can visually see that there are 5 x's here, that way you can remember whether or not you add or multiply. that might be something helpful that you do on the test. So if you just have something like this where they're being multiplied, you add exponents. Whereas if I had something like this where I have an exponent raised to an exponent, this is saying that I want this expression, the x squared, 3 times. So I want x squared times x squared times x squared. And then I could break it down even further, and I could see that when I have an exponent raised to an exponent, they're multiplied. So then the next rule that we have is what happens if I have exponents on top of each other. Since when I'm multiplying, I add exponents. When I divide, I subtract. So I have 5 and 3, and I get x squared. Now, if this was flipped, let's say that we had x cubed on top and x to the 5th on the bottom, I'm still going to subtract these two, but I'm going to put that value wherever the highest number is at. So I would subtract 5 and 3, I'd get 2, but 2 would go on the bottom because the exponent of 5 is larger. Now, if you have an example where you have a negative located somewhere, let's say that you have a negative located on the top, this negative is going to have to move to the bottom to become positive. So when I move this to the bottom, I'm going to have an x to the 4th sitting on the bottom. And so the x to the 4th that's going to move to the bottom, these are now going to be multiplied together. So I have nothing left on the top, so I'm going to put a 1 there as a placeholder. And then I'm just going to take these exponents and add them together to get me x to the 7th. So anytime you have a negative, whether it's on the top or the bottom, you're going to move it to the other location. So if it's on top, you move it to the bottom. If the negative's on the bottom, you move it to the top. All right, the next one is difference of squares, which isn't on your review sheet explicitly, but I do want to go over it because as I was making the key, I found some difference of squares, and there's factoring, but there's not recognizing it. Factoring difference of squares means that the expression is in a specific pattern. And so that specific pattern is, it looks something like this. It can be identified because it's a subtraction sign, and it can be identified because both A and B are perfect squares. So I could have something like 4x squared minus 9, okay? I can indicate that this is a difference of squares problem because A, it's difference indicated by subtraction. 4 and 9 are both perfect squares, so this would be a difference of squares equation. Now, you could use the X method for this, but essentially what you're doing, you're still going to have 2 sets of parentheses. So I'm thinking, how can I evenly divide up 4? So essentially, what's the square root of 4? 2, okay? 2 is going to go first in both sets of parentheses. How can I evenly divide up x squared? X and x. And then how can I evenly divide up 9? 3 and 3. But difference of squares doesn't just mean that this is a different sign. It also means that the signs of your 2 binomials that you're creating are different signs. So one's going to be addition and one's going to be subtraction. The next one is back to probability. So back on your probability part of your packet, the only thing that's going to be asked of you, I believe I should probably take it out and look at it, theoretical and experimental probability. Theoretical, again, means what's supposed to happen, what's predicted to happen based on your possible outcome. So this is what is supposed to happen. Whereas experimental is you're actually looking at some data from people spinning a spinner or rolling a die, and this is what actually happens. So if I'm rolling a die has 6 sides to it. If I'm rolling a die, I want to say, okay, theoretically, and yes, I know I spelled theoretical wrong. Get over it. But theoretically, if I roll a die and I'm going to want to know how many times am I going to land on a 4 shows up on a die once out of 6 possible options. So theoretically, I should land on a 4 1 out of 6 times. Experimental is when you actually roll a die, say 10 times, and what actually occurs. So that 4 could show up 4 times when I roll a die. It could show up not at all. So that's the difference between theoretical and experimental. On the first problem of your packet, when you have to fill in a missing value, all you have to do is put a value that makes that statement true. And that could happen to be a negative number if that's the only thing that makes that statement true. It doesn't mean that it's not possible. It just means that you're going to have a negative in that statement. For mode, there doesn't have to be one mode. Mode can be multiple things. So if you have a number that shows up, say 3 times, and there's 3 other numbers that show up 3 times, then 7, 8, and 9 could all be mode. For range, yes, you take and you find the difference between the largest number and the smallest number, just like you would when you are creating a box and whisker and when you are creating a frequency table. And actually, for those of you who are watching this, there actually is no statistical questions on your test. It stops with probability. So frequency table, histogram, reading surveys, none of that shows up on the Algebra 2 exam. So you'll have a heads up when you get the final. You won't have any of that statistical stuff that we spent Thursday and Friday. None of that will actually be on the final, but it's good to know, especially if you think about going into probability and stats at some point in time during your high school career. Jarrett, what do you want to know in the radical union? That's very general. Do you want simplifying a radical? Do you want adding, subtracting a radical? Do you want multiplying radicals? Do you want solving a radical equation? Radical unit's pretty specific. Yes, Kate, I will have the formulas as well as the posters up on the front of the board for you, and I will be adding to it over the course of the day, just in case I forget something at the beginning of the day. Thanks, Jarrett. Simplifying radicals means that when you are looking at a number, say the square root of 56, I'm looking for factors of 56 that contain a perfect square. And yes, like Kate asked, the perfect square poster will be up on the front. So I'm just looking for some factors that break 56 up. So other than 1 and 56, you would have 2 and 28. You would have 4 and 14. You would have 7 and 8. And so what you're looking for once you break that down is you're looking for perfect squares. So again, you'll have access to that poster. You also have a note sheet that lists out the first 15 of those. But when we're just looking at this set here, perfect squares that we have are 1 and 4. And just to check, I don't think there's any others in there, because if I look at 14 can be broken down into 2 and 7, and neither one of those are perfect squares. So I'm going to use this pair of numbers, and I'm going to rewrite the square root of 56 as 2 square roots, the square root of 4 and the square root of 14. And then I ask myself which one of those simplifies. Square root of 4 simplifies to 2. Square root of 14 does not simplify. So I'm just going to leave that as 2 square root of 14. Now, if there was a number attached outside of that radical, say like a 3, then whatever you got by breaking down just the square root of 56, you would also have to bring that 3 down and combine it with the coefficient that's out front by multiplying, and you would get 6 square root of 14. The only other method I would say for factoring would be guessing and checking. The X method is one way for me just to organize my thoughts, and it allows you to kind of see what you're looking for. But if you want to, the method that I learned to factor was just guess and check, and I didn't actually learn the X method until a couple years ago. So I would say that your X method is the easier way to factor a polynomial. I'm going to wait about a couple more minutes since it's approaching 5. If there are no more questions, I would just send me an email. I'll send you a picture or something of a problem that I worked through. If you're continuing to work on this final this evening and a question comes up, just send me an email. I'll check it until probably about 8:30. And then if I have to, I'll send you a picture. I also might post that on my Twitter, and you could ask me that way. My Twitter account is at KH_LC_MATH. So if you have any questions, you could also send that via a Twitter post or a tweet. Also, when this broadcast is done, this will be a video that goes onto YouTube that is searchable. And so I will be putting that link for this video on my website. It'll probably be labeled final review, something that. So again, I'm going to wait about a couple more minutes just in case any more questions come in. But again, if you miss that deadline and I cut off the broadcast of this, but you still have a question you want answered, you can either, again, tweet it to me or you can email it to me and I'll check those probably until about 8:30 tonight. I would also say that if you email me and that is not a sufficient answer, that I will be here at 6:45 tomorrow morning and you could ask me then. I will not answer any questions up until about 5 minutes before class starts. So don't think that you can walk into the classroom and 5 minutes before you start taking the final, you can ask me questions because I am not going to answer them. I'm so mean, I know. Shutting it down in 30 seconds, guys. 30 seconds. Any last questions? Alrighty, well, I want to thank you for being my trial group. We found out that we have some problems here at school with the Chromebooks blocking Google Plus and YouTube videos at this time. So hopefully next year, if you have me for geometry, that maybe we'll have some of those kinks worked out and you'll be able to use this a little more efficiently. But other than that, thank you for watching this broadcast. Hopefully that helped. Again, email me or tweet me any questions that you may have. Have a good evening.